In this video, we are going to be talking about alternate segments in circles, and then we're also going to work on combining different circle theorems together. The alternate segment states that the angle between the tangent and the chord is equal to the angle in the alternate segment. So if we're looking at our diagram, we can see the angle BAT is formed with a tangent and a chord, and its alternate angle is the angle ACB, so that means that those two angles are equal. Example 1, we're going to start off by finding the size of angle A. So as we just learned, the angle between a tangent and the chord is equal to the angle in the alternate segment. So our angle 54 is formed from the tangent and a chord, and it is the alternate segment of A, so that just means A is also 54. We're now going to work on finding the size of angle B. So we can first just start with writing 54 in for A because we just found that angle measurement. Then you can see that there's a triangle formed between the angles A, B, and 70. That means that those angles have to add up to 180 degrees. This just means that we can add up our two known angles and take that away from 180 to figure out that B is 56 degrees. Moving on to example 2 now, we've got a diagram where A, B, and C are all points on the circumference of a circle that's centered at O. We've got a tangent that's passing through point A. We're given angle BAC is 23 and angle ACB is 71. We're just going to find the angle X. We can see that there is a tangent and it's also meeting up with another chord, so we can consider the alternate segment theorem again. We know that the alternate segment is equal to that angle formed between the tangent and the chord. So X is going to be equal to the angle ABC. We haven't actually been told what that angle size is yet, so what we're going to have to do is recognize that there's another triangle formed with the ABC again. And so we can just take the two known angles, 23 and 71, away from 180, and then we get 86. And because those are alternate segments, X is also 86. We're now going to start working on actually combining different circle theorems together in one problem. We're now going to start on example 3, where we've got a diagram with a circle centered at O. We've got A, B, C are points on the circumference. DCO is a straight line. We also have DA as a tangent. And then angle ADO is 36 degrees. We want to find angle AOD. To start this off, I'm hoping that you do notice that the tangent DA is touching at the same spot as the radius, and the tangent and the radius will form a right angle. So that means angle DAO is 90 degrees, and now we've got a triangle with two of our angles in it. We know that angles in a triangle will always add up to 180 degrees, so you can just add the two that we have together, take them away from 180 degrees to find out that angle AOD is just 54 degrees. We're now using the same exact diagram, we're just going to be looking for the size of angle ABC now. So this is one where angle ABC, the legs of that, end on the circumference at the same point that the center angle of AOC is. So if you remember, the angle at the center is twice the angle on the circumference. This means that angle ABC is going to just be half of 54 degrees, so angle ABC is just 27 degrees. Moving on to our last example, we've got points A, B, and C, which are all on the circumference of the circle. O is again representing the center, and then we've got two tangents, DA and DB. Angle BDO is 22 degrees, and we're trying to work out the angle of X. To start this one off, hopefully we can see that we've got the tangents that are meeting at the radii. So that means we've got two 90-degree angles here. Angle OBD and angle OAD are both going to be 90 degrees because the tangent and the radius form a right angle. Before really moving on to our next step, we have to figure out what our plan is to solve to find out the value of X. So we've got X as an angle that's on the circumference, and it meets at the same edge on the circumference as the center angle does. So what we're trying to do is actually first find AOB before we find X. We also need to recognize that angle ADO is also going to be 22 degrees because that line of OD is splitting that angle in half. So now we've got every angle except AOB in a quadrilateral. We know that those add to 360 degrees, so we can just add our angles up, take it from 360, and get AOB is 136 degrees. Now we can use another circle theorem that we talked about earlier, that the angle at the center is twice the size of the angle on the circumference. So that means angle x is going to be half of angle AOB. So it's half of 136. So that means x is 68 degrees. That's all for this video. If you have any questions, then just leave a comment on Show My Homework and I will get back to you as soon as I can. Thanks.